Hello everyone, welcome back to my channel. So today I've come with a new video on physics and the name of the topic is electricity, and this is going to be the part 3 of electricity, because in my previous video I've already explained you about the basic as well as the detail of the chapter. Today we are going to proceed with the next part, a very small part, and then I'm going to show you small practicals. Okay, so let us quickly finish with our today's objective and then we will proceed with the practical purpose. Now today's topic is concerned with potential difference and resistance. But at first, let us know the conventional flow of current and the flow of electrons between two conductors. Now, I've given you three situations. Now, before that, let me tell you conventional flow of current means suppose if electrons is flowing in this direction, the current will flow in this direction. This is the conventional flow of current, that is opposite to the direction of electrons. Okay, and if you have watched my previous video of that was part 2, I'll give the link in the description. If you have went through it, then you will understand the atomic structure. Now electrons are orbiting the nucleus. It is present in the shells. When suppose, let me give you an example. Suppose there is a house where inside which A is living and outside B, C and D is there. Now suppose if any accident takes place, who will come out at first? B, C and D will come out at first, because A is inside the house, it need to face, open the door, then come out, and it will take time. It need to face some obstruction, but B, C, D is free to come out. Same goes for electrons and protons. Now there any accident does not take place, but what happens is when it comes, means the topic of coming out is being concerned. Okay, then at that point of time, who will come out? Electrons will come out, because protons are in the nucleus. It cannot come out like this because it needs to face a lot of difficulty. But electrons are present in the orbit, and as soon as it will come out of the attractive force of the nucleus, then at that point of time, it will become a free electron and it will constitute electricity. So in that point of a case, electrons are more free to flow. So based on that, we have three situations. When one is positively charged, another is negatively charged. When one is uncharged, another is positively charged, represented by U. And when one is uncharged and another is negatively charged. Okay. So if suppose A, which is positively charged, and B, which is negatively charged, then in that point of time, as I have told you, electrons will flow. Then electrons will flow from B to A. And what will be the conventional flow of current? It will be from A to B. Now coming to the second factor. When one body is uncharged, another is positively charged. Then electrons will flow from A to B, because here we have no electrons. Okay. And here we have electrons. Why is it uncharged? Because it is neutral. But electrons will flow from A to B. And what will be the conventional flow of current? From B to A. And so third case, when one body is uncharged, another is negatively charged. Then the electrons will flow from B to A, because this is negatively charged, and current will flow from A to B. Okay. Now coming to potential, which is our main topic of today. Before that, let me tell you one thing. If a body is having an excess of electrons, it is said to be at lower potential or negative potential. And if a body is said to be at deficit of electrons, that is having lower electrons, then the body is called at higher potential or positive potential. Okay. Now suppose we have 2 points. Now at first let me tell you about potential only, then I'll tell you about potential difference. Now here I am using point A and B, but definition wise we tell infinity to a point. That means one point will remain, another will turn out to be at infinity. But here, since I am explaining you, that's why I am drawing 2 points. And suppose electrons are present here and we want to bring it from A to B. Then in bringing one electron, some sort of work needs to be done. So that amount of work done per charge or a unit charge is called your potential. potential V. Okay, for the timing I am represented it by potential. I am writing this full thing. So amount of self, if I am just taking out this one and if you want to bring it this way to B, then some amount of work needs to be done W. And what is the charge of electron? I have already told you in my previous video. So in bringing this unit charge means one charge, Q is your potential. Okay, so potential equals to W by Q. Now coming to potential difference. Suppose there are two, I am not drawing this, I am just telling you like this. Suppose there are two ends, not suppose, it's in actual only. There are two ends of a wire. So the amount, the difference of potential between the two ends is told to be potential difference. Now I have taken the example of wire, but definition wise it will be something different. Now I will recommend to follow the definition that is given in the respective books. Okay. So for the explanation purpose I have used the example of wire. Okay. So I repeat that is the difference between the potential of 2 points. So how we can find the difference? Suppose potential representing it by W, sorry V, V1 minus V2 equals to what? Work done per charge. Okay. If we are talking about the unit, then W means what? Joule. Charge means what? Coulomb. Charge means what? Coulomb. Right? So joule per coulomb represented by volt, written as small v, and potential difference represented as capital V. Okay. So that was all regarding potential difference. Now coming to resistance. Now resistance is nothing other than the obstruction offered to the flow of electrons. So I repeat, resistance is nothing other than the obstruction offered to the flow of electrons. Therefore, according to Ohm's law, what we tell is V equals to IR. This is Ohm's law. Ohm's law, V equals to IR. Okay. Or R, that is resistance, equals to V by I. So potential difference per current, that is V by I, is your resistance. Okay. If we are going towards a unit, then V means volt represented by small v, or I am writing the spelling. Current is I is current, unit is ampere, that is small v A, volt per ampere. This volt per ampere is also written as ohm, and ohm is represented by omega. Okay, omega. Omega is nothing other than a Greek letter, but this is the representation of ohm. Okay. Now we have four factors that affects the resistance. What are the four factors? First factor is temperature. If the temperature is high, temperature is inversely proportional to resistance. If the temperature is high, ions will gain more kinetic energy, it will move more faster, and electrons will flow. Okay, means and electrons will be flowing, right? So if ion starts moving, the electrons will be facing some amount of obstruction. So resistance will be there. So in temperature is inversely proportional to resistance. Next, length of the wire. Length of wire. Length of wire is again inversely proportional to resistance, because more the length, more the amount of distance the electrons need to travel. So resistance will be high. Third, area of cross section of the wire. Area of cross section of wire. Area of cross section of the wire is directly proportional to resistance. Why? Because if the area is high, that means the electrons will get more space to travel, and in that point of case resistance will be higher, sorry, lower. Acha, these things I've told you one thing wrong. They are inversely directly proportional. This is inversely proportional. Okay, these all are directly proportional. These two. If temperature is higher, resistance will be higher. If length of wire is more, resistance will be more. These two are directly proportional. This is inversely proportional. Area is inversely proportional to resistance. Okay. Third is material of the wire. Now material of the wire means resistance varies from one material to another. So here we does not have any relation like this. Okay, and in the beginning while explaining the topic I have told you these two to be inversely, but sorry to tell that this will be directly proportional. Okay, and not inversely. Now let us proceed with our small practicals. So this was all for today. Okay, so we have completed with our electricity. Okay, as I am doing two numericals, small numericals. Two formula we have learned, that is V equals to IR. From here, this is the formula which we will remember, and from here only we will find our resistance. Another is V equals to W by Q. This is when individually we are finding potential difference, so we will use this formula, and when we are concerned with resistance, then we will use this formula. Okay. So suppose if V is 2, current, V is 8, suppose current, that is I, is 2, and if we want to find the resistance, then R will be equals to 8 by 2, that is 4. Therefore R equals to 4 omega, that is ohms. Here suppose we need to find the volt potential difference, then suppose our work done is 8, current is 4, then it will be 2, therefore volt equals to 2, sorry, not volt, potential difference equals to volt, 2 volt. Okay. Now coming to our practical one. Now in my previous video I have told you about two instruments, voltmeter and ammeter, and I have told you that in today's modern generation we have a instrument which have both the characteristics of ammeter as well as voltmeter. Okay, today I am only going to show you voltmeter because I don't have any circuit ready with me which will help me to show you the ammeter. Okay, so today, now voltmeter means what? It measures the potential difference. Okay, now I have this battery with me. Okay, we will be measuring the voltage, volt of this one. Now the instrument name is multimeter. This is multimeter. Okay, we have two connections like this, and these are the 2 points. Okay, which we will be attaching with the battery. The red one represents positive, black one represents negative. So let us now take our battery. Now before that, let me tell you one thing. Okay, let me show you this at last. But before that, let me show you few basics. Okay, of electricity, like the key and your bulb, and then let me show you the multimeter. Okay, because at first let me show you the components and then let us proceed with our multimeter. Okay, so at first this is a bulb. Okay, this is a bulb that this is a normal LED bulb that we use for practical purpose. Now it has one speciality. What is the speciality? Suppose if this is a bulb, then one side is shorter and one side is longer. Shorter side represents plus, longer side represents minus. Sorry, shorter side represents minus, longer side represents plus. Okay. So you can see that this is the short side. Okay, I have just bent it like this in order to just recognize it while making circuits. and this is the longer side which represents your plus. Now this is a switch. This is a switch. If we are pressing the switch, then circuit gets completed. If we are turning off the switch, then the circuit gets disconnected. Now this 1 represents turning on and 0 represents turning off. Okay. I also want a more type, that is the tapping key. The amount of time we will keep it pressed, for that particular amount of time the circuit will get complete. As soon as we will release it, again the circuit will get disconnected. I have also the smaller version, this one. This is a smaller version, very small. So here we have a button type something. Okay, the amount of time we will be pressing it, the electrons will flow, the current will flow, and circuit will get completed. And as soon as we will be releasing it, then the circuit will get disconnected. Okay. Now this is a crocodile clip. Okay, about this I have not told you in my previous video. This is a crocodile clip. Now what is the work of crocodile clip? Suppose this is a circuit. Okay, I am just taking this wire. Suppose this is the wire of a circuit. And if you want to attach two wires like this, either we need to solder it like this if you want to attach it. Either we have to solder it, or we have to do something. Okay, either we have to roll, means put sellotape, or we need to tightly fasten the two wires. But simply, how can we do it? We can take the crocodile clip and we can put it like this. This will make the circuit completed. Okay. Therefore, like this we can complete a circuit without soldering, because the time we need to open everything, at that point of time the ones which are soldered, they cannot be opened. Like here I have soldered the wires with the switch, so they cannot be opened. If you want to open it, something or the other will get destroyed. But using crocodile clip, we can just simply attach it like this in order to make the circuit complete. Now in my previous video I have also not told you about DC motor. This is a normal fan DC motor. Okay, and this is a gear motor. This is a gear motor. This is found in toy cars. Okay, in cars, toy cars normal, this is found. Okay, these two white portion we attach the wheels and the wheel rotates. And here in case of this DC motor, it's like if you are attaching the propeller like this. I have the small propeller as well as big. This is the big propeller, this is the small propeller. I am attaching the small one. If we are attaching the propeller like this, and if electricity is attaching it to a battery, then it will rotate like this. Okay. Now, in order to supply resistance, okay, in my previous video I have told you about resistance box, rheostat. Now we have small resistors also, like this. These are the small resistors. These are the small resistors, okay. It has different value, different resistor represents different value of ohm, and like this we can have different resistance. Okay, I have many resistors with me. We can measure it using the multimeter, and then we can use it as per our requirement. So these were the basic things. Okay, last thing let me show you regarding this, then I'll show you the multimeter. This one. This is a connecting wire. While proceeding with the first topic of today, I have shown you that A and B, two body conductors, and I have drawn on wire. Okay, I have drawn a line which represents the wire. So this is the wire. This red color part is the insulation. This red color part. This is the insulation. We can remove the insulation using scissor or any mean, and we can have the copper wire inside it or any kind of material which you are using, and we can ultimately get our circuit done. Okay. And here's the tapping key that I have shown you. This is different from the laboratory one. Okay, laboratory tapping key is of different type. Okay, but this is also a tap key. Now, let me show you the thing that I have told you, that is measuring the volt of a battery. Now, this is a 1.5 volt battery. Okay, 1.5 volt. Now, black represents minus, red represents plus. Now here it is already written in the battery, this side is plus, this side is minus. So let us just, before that we have to adjust this thing of the multimeter. So this is the section of volt measurement. So we have to adjust it like this. Okay. Now we will be holding our 2 point of this, like I'm showing you like this. Okay, we have to hold it like in this way. I'm just showing you, just a second. So this is the way we have to connect the two ends, and see, the reading is already given. The reading is already given. 0.13. I've used a very old battery, so it is almost towards the ending. Okay, it's a primary cell. Okay, so it's almost towards the ending. But in order to show you, I've used this battery. So the reading is 0.13. Now here it is showing a digital. In digital it is showing the numbers, but in case of your voltmeter, okay, practical voltmeter, then there you will have needles. Okay, you will have a needle that will ultimately show you the value. Value will be marked and the needle will deflect and it will show the value. Like that we can have our voltmeter. But since this is a merged version of ammeter, voltmeter, and we have many other features of this, therefore it shows a digital value. Even we can, using the multimeter, we can even measure transistors. Okay, we have many useful purpose of multimeter in the field of physics practicals. So this was all for today. Hope you have liked my video. If you like my video, please like, share and subscribe it. Also press the bell icon to get the notification of my uploaded video. In my next video, I will come up with some more interesting topic. And for the time being, bye everyone. And if you have any kind of question or anything, I'm always there to help you. You can ask me in the comment box. Thank you.